In our previous video, we tried to understand the thermal control function of a battery management system, and in today's video, we are going to see the cell balancing function. When a battery pack is new, all the cells within the battery pack have similar SOC and capacity. But over time, due to various factors like manufacturing variations, aging, and various operating conditions, the cell-to-cell similarity degrades. Cell balancing is the process in which a battery management system ensures that all the cells within a battery pack have equal charges. The reasons why cell balancing is important are: cell balancing maximizes the overall usable capacity, allowing for longer range, improved performance, and extended battery life. Two methods for cell balancing are active cell balancing and passive cell balancing. Active cell balancing involves redistributing the charge from stronger cells to weaker cells during the charging and discharging cycle, whereas passive cell balancing involves dissipation of energy from higher voltage cells, removing excess energy through a resistor until charge matching entire cell voltage to lowest cell voltage. Now, GT Suite can assist in creating these cell balancing strategies. Engineers can model cell resistors, switches, along with control algorithms and battery management logic to evaluate and optimize both passive and active cell balancing strategies. You can also compare degradation between balanced and unbalanced battery packs.